Hello friends, welcome to my channel Physics Moji. Today's video is regarding the refraction of light activities part 5. Before going to this video, make sure that you have watched all the remaining parts, that is part 1 to part 4. Now let us go into the video. In the last video, we have discussed about total internal reflection. In this video, we are going to discuss the applications of total internal reflection. First, let us discuss about the formation of mirages. Now, we are going to discuss the formation of mirages. So, what is a mirage? Mirage is an optical illusion. Mirage is an optical illusion. So, what do you mean by optical illusion? We know when we travel on the roads during daytime, you can observe that some of the water has collected on the surface of the road at a far distance from you. But when you go there, we did not find any water on the surface of the road. And we know one of the best examples that the oasis. So in the deserts, it observed that some water has collected on the surface of the sand, but when you go close there, you did not find any water. So illusion means it appears like they are present, but actually they are not present. So mirage is an optical illusion. So these can be called as mirages. These optical illusions that are caused can be called as illusion. So this is due to optical illusion. And what is the cause of the formation of mirages? Let's see. So mirage is an optical illusion caused by atmospheric conditions, especially the appearance of a sheet of water in a desert, so that is here, or on a hot road, caused by total internal reflection. So the main cause is total internal reflection. So we already discussed in the last video about total internal reflection. So why the total internal reflection takes place? What are the conditions for taking place of a total internal reflection? Now let's have a look on it. We know when the light ray is traveling from denser medium to rarer medium. So let this be the denser and let this be the rarer medium. So here you can observe that the light ray is traveling from denser medium to rarer medium. So when the light ray is traveling from denser medium to rarer medium, it bends away from the normal. So let this be by angle of incidence, let it be I1, and the angle between the normal and the refracted ray is angle of refraction. So this is angle of incidence and this is my angle of refraction. Now I further increase the angle of incidence. So this is my angle of incidence I2. So this is angle of incidence I1, and here I further increase the angle of incidence. So you can observe that the angle of refraction also got increased. So this is my angle of refraction, let it be R2. So that the first one be R1 and this is R2. Okay, so what happens if I further increase the angle of incidence? So now I am further increasing the angle of incidence, and let this angle be my angle of incidence and let it be I3. So if you observe here, the refracted rays are further bending towards the interface. So this is the interface between the two medium. In the third case, the light ray has fallen, the refracted ray has fallen on the interface. So the angle between the refracted ray and normal is a right angle. So the angle of refraction is 90 degree here. Okay, so we already discussed in the last video that the angle of incidence, the angle of incident at which the angle of refraction becomes 90 degree is called critical angle. So this angle I will call it as critical angle. This I call it as critical angle. So What happens if I further increase my angle of incidence more than critical angle? So this is my angle of incidence, and we can see that this angle of incidence is greater than the critical angle. So this is my critical angle, and here my angle of incidence is greater than the critical angle. So if you observe, the light ray is not getting refracted, it is getting reflected into the same medium again. Okay, so this process of bouncing back of light into same medium is called total internal reflection. This phenomenon is called total internal reflection. So when my angle of incidence is greater than critical angle, the light gets reflected into the same medium. It will not go to the rarer medium. It reflects into the denser medium again. This phenomenon is called total internal reflection. So this is the cause of the formation of formation of mirages. Let's see. So if you have, let's see the formation of mirages. So this is the surface of the road, and the air near the surface of the road is very hot. So this is hot air. Okay, and we know the hot air will have more temperature. So this is close to the surface of the road, so the height is less. So what we can say, at less height the temperature is more. As height goes on increasing, the temperature will decrease. As a result, the density goes on increasing, whereas the density of hot air is less. So as the height increases, the temperature will decrease. So the air near this place at heights, the air will be cool. So this is cool air. We know sun is the source of light. The light has to travel through cool air to reach the surface of the road. So when the light is traveling, you can observe that the light ray is passing through the cool air, which we are treating it as denser medium because of its high density. So the cool air is denser medium and the hot air is a rarer medium. Okay, so the light ray is getting passed from denser medium to rarer medium. So we already discussed in the last slide that the light ray is traveling from denser medium to rarer medium. When my angle of incidence is greater than the critical angle, then it gets reflected into the same medium. So it is not traveling into the hot air surface. Okay, so it is getting reflected into the same medium. So when you extend this, you will get the virtual image of the tree on the surface of the road. Okay, and the virtual image of sky on the surface of the road. So this is because of total internal reflection. So here you can observe that the light ray is not traveling to the other medium, it is getting reflected into the same medium again. Okay, because of this the mirages are formed on the surface of the roads.
Now let's see about the brilliance of diamond. We know that a diamond will sparkle grey and white, which we call it as brilliance of diamond. When we take a glass and a diamond cut into same shape, you can observe that the diamond shines more when compared to glass. What would be the reason for this? The reason is the less critical angle of the diamond when compared to glass. Because of this less critical angle, the total internal reflection takes place at a very low angle of incidence. As the critical angle is low, the total internal reflection will take place at a very less values of angle of incidences. So if you observe the figure, you can observe that multiple reflections are taking place in the diamond, and you can observe that the angle is very less. So because of this multiple reflections that are taking place in the diamond, it sparkles, which we call it as brilliance of diamond. So the brilliance of diamond is due to total internal reflection. The next application of total internal reflection is optical fibers. Let us see the working of optical fibers. We can see the core and cladding in the diagram. So the light is incident in the part of core, and this core is surrounded by cladding. Here the light is incident in the core part, which acts as denser medium, and the light is incident at an angle greater than the critical angle, such that if you observe here, the light is traveling only in the core part, it is not entering into the cladding. So because the core acts as denser medium and cladding acts as rarer medium, we know that when the light ray is traveling from denser medium to rarer medium at an angle greater than the critical angle, total internal reflection takes place, such that the light is getting reflected into the same medium. This is how the optical fiber transmits the optical signal from one end to the other end of the optic fiber cable. Now let us see the uses of optical fiber. The first use is the optical fibers are used in telecommunications. Then the optical fibers are used in the medical field for the diagnosis of internal parts through endoscopy. We know that all organs of the human body are not accessible to the naked eye of the doctor. So the doctor inserts an optical fiber pipe into the stomach through the mouth. This light is sent down through one set of fibers in the pipe. This illuminates the inside of stomach. The light from the inside travels back through another set of fibers in the pipe, and the viewer gets the image at the outer end. Generally, it was fed to the computer screen as shown in the figure. And the next application is the optical fibers are also used in meteorological departments. So we know we'll see the weather forecasting every day in the news. So it was made with the help of optical fibers, and the optical fibers are also used for finding refractive indices of liquids. Okay friends, in this video we have learnt about the formation of mirages, brilliance of diamond, and the working of optical fibers and its uses. Thank you for watching my video, and I hope you liked the video. Make sure that you have watched all the remaining parts of refraction of light activities from part 1 to part 4. The links are given in the description. If you like our videos, please do like, share and subscribe to our channel. Thank you.